Ladies, thank you for joining me. We are in Chapter 5, Goal 12, Roman numeral 3. Use the half-angle formulas to determine the exact value of sine, cosine, and tangent of an angle. So if we look at A, if I'm asking you to find the sine of 165 degrees, we know that 165 is not one of our special angles with a reference angle of 30, 45, or 60 degrees. So we need an alternate way with which to solve for this. We could use sum and difference formulas. We might somehow be able to use a double angle formula, but that probably wouldn't be so easy here. I want us to practice, however, using a half angle formula. So when we're using a half angle formula, this angle represents the half angle. So we know that our half angle is equivalent to 165 degrees. If our half angle is 165 degrees, then we would also need to solve for the whole angle. In order to solve for the whole angle, we would multiply both sides by 2. And our whole angle is 330 degrees. So this will be useful to us after we expand the half angle formula for sine. Recall that the half angle formula for sine is plus or minus. We'll go back and fill that in just a moment. The square root of 1 minus the cosine of angle x, all divided by 2. So we know that it's plus or minus. How do we know whether we use the positive or negative? Remember, that depends on the quadrant of the half angle. 165 degrees is in quadrant 2. So in quadrant 2, sine is positive. So this will be the positive of 1 minus the cosine of angle x. We have determined that angle x is 330 degrees, all divided by 2. So we know that the cosine of 330 is, reference angle is 30, so that's square root of 3 over 2. We are in quadrant 4, so that's positive square root of 3 over 2, all divided by 2. When we find our common denominator for 1 minus root 3 over 2, that gives us 2 minus the square root of 3 over 2. And when I keep it, switch it, and flip it, in other words, multiply this by 1/2, I'm multiplying here this by 1 over 2. So I'm showing that right here. That would give us the square root of 2 minus root 3 all over 2 times 2 is 4, and you know that the square root of 4 is 2. So this is the square root of 2 minus root 3 over 2. I'd like you to go through the same process for the cosine of 165 degrees, so pause the screencast, calculate the cosine, and then turn back on to check your answer. Okay, let's check the cosine of 165. We chose the negative because the half angle 165 is in quadrant 2, and in quadrant 2 cosine is negative. And then we expand 1 plus the cosine of angle x, which is 330 degrees divided by 2. We know the cosine of 330 is positive root 3 over 2. When we find a common denominator and add 1 plus root 3 over 2, it gives us this sum. When we divide by 2, we keep it, switch it, flip it, or multiply by the reciprocal. That gives us a denominator of 4, and the square root of 4 is 2. So if you compare our sine of 165 and our cosine of 165, there are just a few slight differences. Remember, we can use those to calculate the tangent of 165 degrees. So to find the tangent of 165 degrees, let's use the sine of 165 degrees divided by the cosine of 165 degrees. So the tan of 165 is equivalent to the sine divided by the cosine. Well, I see right off that the denominators of 2 would cancel. So our tangent is the square root of 2 minus the square root of 3 divided by negative square root of 2 plus root 3. And remember, you do not have to rationalize. All right, let's finish up with a value in radians. You can convert this to degrees, but I want to work on it in radians just to show that the same properties apply. What I'd like you to begin by doing is remembering that if we're using the half angle formula, this represents our half angle. So I'd like you to first determine the whole angle. So if the half angle is pi over 12, then we know we would multiply by 2 to find the whole angle. And if we multiply by 2, 2 times pi over 12 is pi over 6. So we know that our whole angle is pi over 6. All right. Would you pause the screencast and expand and fill in the formulas for sine and cosine of pi over 12, then turn it back on and check your answers. Okay, so you'll see that I have, in the place of cosine x, I've replaced it with cosine of pi over 6 because that represents the whole angle. And then you also will notice that I've replaced plus or minus with just the positive. How do we know to use the positive? Because pi over 12 is in quadrant 1, and all angles in quadrant 1 are positive. So at this time, I'd like you to pause the screencast again, evaluate and simplify both of these half angle formulas for cosine. This time I used my calculator to simplify the two radical expressions for me, and we have the square root of 6 over 4 minus the square root of 2 over 4, and then the sum of that. Let's take the sine and divide by the cosine in order to calculate the tangent. And I want to use the calculator this time to do that for us. So you can see that it will simplify it for you. So you notice that I'll have the sine of the half angle divided, or the sine of pi over 2 divided by the cosine of pi over 2, and this will give me the tangent of pi over 2. And I know that's a crazy looking value, but remember that they've taken this and rationalized it completely. Thank you, ladies. I hope this helps you with your half angles.